Okay, I modified some due dates right before class. We should be done covering this on Friday. So I moved the due date, I took it away from Sunday night and I put it on Tuesday. So that would be this quiz in OWL chapter 2, part 2. Like I said, we should be done Friday, I'm hoping. This I put on Sunday midnight, I think it is. So with that, anybody got any questions on any of these on this compounds quiz? Anybody got a question on any of these on the compounds quiz here? Shoot me a number, somebody. Shoot me a number, shoot me a number. Which one? 11. All right. All right, 11. So for 11, we've got manganese 2, and then hexacyanopherate 2. So hexacyanopherate 2 is Fe, left parentheses, Cn, right parentheses, 6. And that 2 actually is the charge of the iron in there, but this entire thing is -4. Therefore, if that's a -4, we are going to need another manganese 2. And for a formula, we would end up with and then 2 Fe, C, and 6. Any other ones on this baby? Yes. 32, 32. Let's see if we can master that 32. I'll give it a shot. 32. Which of the following is written incorrectly? Okay. Now, 32. And there might be a little hiccup in 32, I'm not sure yet. One way to look at that is say, is that right there nitrite? If that is nitrite, then nitrite is -1. That would have to make aluminum +1. But let's come back to this. Maybe we got to break this down even more and treat that as an oxide. So let's see if we can find one and maybe come back to this, because there is some possibilities to look at that another way. This right here, though, we should have carbonate here. So if that is carbonate, carbonate is -2. So that would mean we've got lead 2s on these to get 0. And there is no lead, or excuse me, lead 1. There is no lead 1, right? CuO2 in letter C. What I would do is I would assume that's oxide. So you would have copper, OO oxide, -2, -2, +4 on the copper. And there is no copper 4. So that doesn't work. However, this O2 could be peroxide, right? And if that is peroxide, you have CuO2 as -2, copper 2. So then you would have copper 2 peroxide. And that's valid. So we know we can have copper 2 peroxide here would work. In D, we have LiS. Well, sulfide's not -2, but that would assume you'd have to have a lithium, which is a 2, and that doesn't exist. In E, you would have to assume that those O's are oxides. So you'd have -2, -2, -2, -2. And the nitrogen would have to be a +8. So C for sure does work as a peroxide, right? Not as an oxide, as a peroxide. Yeah, that's a good question. Because down here we have more of these polyatomic ions in parentheses. If I spend more, that one might work out if we get it individually. Somebody get A to work out. Okay. All right, let's close the book on this. If you got a pressing question on this baby, we can still do it on Friday. So as we go today and finish up today, you're going to be able to do more of this quiz, and towards the end, like so far I said, you should be able to do 1 through 13. And we'll expand on that after today. So let's move back to moles. Moles. Let's review. We know that if we have 1 mole of aluminum, it's going to be 26.98 grams, right? We get to use all of these numbers. Boron, 10.811 grams. And if we use 10.811 grams on here, we have 6.022 times 10 to the 23rd atoms, right? This is a chart where if we use this number in grams, it's all for 1 mole, and 1 mole is 6.022 times 10 to the 23rd atoms. I said similarly, we can make a chart of all the different eggs. And we know a pigeon egg would be small, or excuse me, a robin egg would be small, and a different color, by the way, compared to a pigeon egg, compared to a chicken egg, compared to an ostrich egg. But we can make a chart that was the mass of 12 eggs, right? It will look similar. Or we could use any ratio of this. So we could do 10 moles, right? We multiply it by 10. We could do 1/10 of a mole. So again, when we use these numbers, because we're going to do everything in grams, then we know we're doing moles. So what we're going to do now is we're going to figure out some masses in moles, because later on, we are going to take our formulas of compounds that you know how to write. We're going to identify what type of reactions we have, and then we're going to put the numbers to the reactions. Stoichiometry, right? Okay, so I encourage you to get your calculator out and calculate these with me, because some students still push their calculator the wrong way or enter it the wrong way, and this will verify that you are entering it correctly. So we are going to do a problem here. That's grams to moles. Moles to grams, grams to moles to atoms. So, which means we're given grams, we got to find moles, right? So you could probably match this up and use this. Grams to moles again, moles to grams, grams to moles to molecules to atoms, and the last one. Now, there are only 2 conversions we are going to use. Okay, the 2 conversions I'm going to put on top. We're going to use 1 molar of something, and that is going to be either atoms, molecules, I'm going to leave it at that. I'm just going to use atoms molecules. No, I'm not. Ionic compound. And that is going to equal to 6.022 times 10 to the 23rd atoms, molecules, or ionic units. And then the other conversion is, I'm going to put it right here. You have 1 mole of atoms, molecules. Ionic compound is equal to grams, right? Those are the only two conversions we are using. 1 mole to grams or 1 mole 6.022 times 10^3. And realize it is always 1. It is 1. 1. Okay, so let's do this. Grams to moles. So we're going to start with the only given thing we're given. Please, please, please write in what you have for units. Grams of potassium. That's your starter. We know that we have to cancel out grams of potassium. It is no different than what we've been doing. So the conversion I'm going to put in here is grams of potassium down here in mole, 1 mole of potassium. Where am I going to get that number? Periodic table, right? Periodic table for potassium. We are going to use 2 decimal places except for the elements, hydrogen, lithium, beryllium. We'll use 3 decimal places. But otherwise, you can assume 2 decimal places. And for potassium, at 2 decimal places is going to give us what? 39.10. We're going to have to move that up a little bit. So we've got 39.10. We know then that grams are going to cancel out. And we can solve this. We're simply going to divide this, and sig fig wise, we started with 2 sig figs. We're going to end with 2 sig figs, right? And if we end with 2 sig figs, we should get 0.12, right? 0.12 looks good? 0.12. Okay. This next one, we have 9.2 times 10 to the minus 4 moles. Let's take this out of scientific notation. So if we move this 3 to the left, we are going to start with 0.00092 mole of argon. We know that we are going to eliminate moles. So this time, when 1 mole is going to go down here, I want grams. So 1 mole is how many grams of argon? And check your periodic table. It is a noble gas on the right side of your periodic table. And this focuses by cheating this way. And it does not focus very well. 39.95. 39.95 grams for argon. We are going to cancel out moles. We started with 2 sig figs. We're going to end with 2 sig figs. And if we end with 2 sig figs, I believe we get 0.037 grams. Is that right? Okay. Next one. We have grams of copper and we want atoms. So we are going to start with 5.00 grams of copper. Now, I always say this in chemistry, if you're not given moles and if you don't have a clue what to do, somehow find moles, right? Somehow get the moles. So, well, we're going to do that here. We're going to put grams of copper down below. We're going to put our 1 mole of copper up above. And for copper, we would get 63.55, 63.546. So 63.55. Grams of copper cancel out. And then you ask yourself, well, do we want moles? Because if we want moles, we're done. But we don't want moles, so we got to do another step. We're going to use the other conversion. And that is one mole of copper, 6.022 times 10 to the 23rd. Copper atoms or atoms of copper. Now we can cancel out moles. So this time we just use both conversions. Again, it's just 1 mole, right? 1 mole. So please, please, please grab your calculator. Make sure you're not putting in times 10. And what are we getting?
4.74 e to the 22.
4.74 to the 22? 4.74 times 10 to the 22 copper atoms, huh? That's right, vertical nods. Vertical nods. Oh, I like to see vertical nods instead of the horizontal ones. Okay, please don't overcomplicate this. It's 1 mole to grams or 1 mole to Avogadro's number 6.022 times 10 to the 23rd. There is some good Tyler DeWitt videos, does the same thing. Okay, now notice that everything up here was atoms. Now this is a molecular compound, glycine. So the only thing that's going to change is we're going to have to add up to get the molar mass, right? If we need grams out of this. So let's see what we got. We got grams. So I'm going to start in blue. Ooh, we got 4 sig figs. We've got 28.35 grams of glycine. C2H5O2N. And I want moles. So 1 mole C2H5O2N. If you do not write in what you're talking about, oh, it drives me insane. You have to put grams in here, right? You have to write this in. Now we need grams of C2H5O2N. So good time to review, because you're gonna start memorizing these. Okay? Carbon. 12.01. Hydrogen. 1.008. Oxygen is 16.01. And nitrogen, 14.01. You will start memorizing those. Or oxygen is just 16. One of them doing? I got 01 happy. Oxygen is just 16. So grab your calculator. You need 2 carbons, 5 hydrogens, 2 oxygen, and a nitrogen. And if we add all those up, what do we get? 75.07, 07, 08, 09, 07. Let's see in the vertical notch yet. 07. Okay. And we're done, right? We are done. So we can cross this out. And we are going to get .377. What do we get? 4 sig figs. 37 what? No. 0.37 what? 76? 76. We're probably going to chop this hydrogen to 1.01 because it doesn't do any good when we're adding those up. We don't gain anything. 3 decimal places, 2 decimal places, 2 decimal places, 2 decimal places. We'll probably round that to 1.01. Okay. Vitamin C. We got moles. So let's go with our starting of 0.00. We'll take this out of scientific notation. 0.142 mole C6H8O6. We just need to go in moles to grams. 1 mole C6H8O6 is how many grams of C6H8O6? Yeah, we'll just use 1.01 for hydrogen. So 12.01, 1.01, 16.00. So the molar mass for vitamin C at C6H8O6, we need to get that magic number up here first. 176.14. All right. Let's see. I like vertical now. 176.14. And we're done, right? Moles are going to cancel out. And I realize whatever you have in your calculator, you're going to keep it, just multiply by this, right? You don't even have to clear your calculator. So once you multiply that, you get How many sig figs? We got 3 sig figs here. So 3 sig figs is gonna give us what?
0.025.
0.0250, huh? That would get us 3 sig figs. This 0 counts, this does not. Grams of C6H8O6. All right, this last one, we got to go way to the left on this baby. So we got 40 milligrams of saccharin. So we are going to start way over here to the left. 40 milligrams. How many grams? We going left with the decimal or right with the decimal? 3. We're going left 3. And that is 3 sig figs. We got to start way over here above the punch out at 0.0400 grams of C7H5NO3S. And the first thing, if you're giving grams, you got to convert grams to moles, no matter what. So 1 mole up here of C7H5NO3S. And grams of C7H5NO3S. And what is the molar mass of saccharin? $181? $181? Are we going this way on 181? What do we got? 180 what? 181.11? No. Higher? What do we got? Who's got a molar mass here? I'm not getting vertical now, it's at 181. What do we get? 183.2? 183.2? All right, vertical now is at 183.20. So 12.01, 1.01, 14.01, 16.00, and this thing ends up rounding to what? 32.07? I think those are the numbers we used. If everything's at 2 decimal places, right? And this is correct for significant digits. Because we end up adding numbers, 2 decimal places, 2 decimal places, 2 decimal places, 2 decimal places, 2 decimal places. So let's see, let's keep going because we're not done. We got, ooh, we need to get atoms and we just want atoms of carbon out of this thing. Before we get to atoms, let's get to molecules. So now we can go 1 mole of saccharin would have 6.022 times 10 to the 23rd. It's all non-metals, so I'm going to use the term molecule. It's all non-metals. This is going to be molecules. of C7H5NO3S. Ooh. Grams cancel out, moles cancel out. Now, our last step is every time, we'll move this to the left. For every one molecule of C7H5NO3S, it contains 7 carbon atoms, right? So that's what we're going to do. We're going to cancel out molecules. We're going to go 1 molecule of C7H5NO3S. NO3S, I did sneak it in. You have 7 carbon atoms. Ooh, made it. And this is unlimited sig figs here. And we've got 4 here, we've got 5 here, we started with 3, so we're going to end with 3. And if we end with 3 sig figs, our final answer is so what you should do is take 0.04, multiply, hit equals, and hit divide. Then we get 3 sig figs. 9.20 to the 20th. Okay, 9.20 times 10 to the 20th carbon atoms. All right, let's go to the next page. On the next page, percentage composition, 5 mass. So what we want here, because this is going to lead us up to the next part, calculating empirical formulas. If you have aspirin, C9H8O4, what is the percentage composition by that? What is the percent carbon? What is the percent hydrogen? And what is the percent oxygen? Now, what does percent mean? Percent really means per 100. But I can't say how many males are in here out of 100 people, right? Because we don't have 100. So then we cheat and we simply do part over the whole, and then we multiply it by 100. And we add a percent sign. So then if you do not have 100, you just do part over the whole, and assuming if you had 100, you would get the same thing. So we're going to do here for aspirin, we do the percent carbon first. On the molar mass of this, there are 9 carbons. We would go 9 times 12.01 for the carbon. That's the part carbon over the whole. Now the whole would be the whole molar mass. So we have to add up 9 carbons, 8 hydrogens, 4 oxygens. So what is the molar mass of aspirin when we do that? And again, you're going to memorize these because you now have memorized carbon as 12.01, hydrogen at 1.01, and oxygen at 16.00. We'll put that on the screen. There we go. And what is the molar mass, the complete molar mass?
180.17.
180.17. Okay, and we could put grams, AMU, something. We know we have the same units. If we had a mole, I guess we could put grams in there. And then we're going to multiply that by 100 and add the percent sign, and we would get, how many sig figs we got out of this? I guess we got 4. Yeah, we got 4 sig figs. The four sig figs, what do we get for a number?
59.99.
59.99? 59.99? 59.99? Okay. How come I had 60 points? Okay, 59.99. 4 sig figs. Yeah, we got to do it that way. 4 sig figs. 59.99. Okay. So 59.99% carbon. And then if we did, let's see, we might as well do hydrogen here. We're going to get in trouble. We're probably going to have to sacrifice some sig figs coming up here. So if we do hydrogen next, that is going to be 8 times, here is where I would add 1.008 here to get this more accurate. And over the entire molar mass again, 180.17. Yeah, that would keep us to 4 sig figs everywhere. And grams and grams. So multiply that by 100, add the percent. What do we get for this? Four point what?
4.475.
4.475? 4.475, and that is 4 sig figs, 4 sig figs, 4 sig figs. Percent. Now, we do not have to calculate the last one like we did before, because if we had 3 items that we're trying to do the percentage for, they all have to add up to 100. So we can go up here and do a little cheat method and go like this. The percentage of oxygen is going to be 100.0 to give us 4 sig figs, or 00, doesn't matter. We're assuming we've got a perfect 100. We're going to go minus 59.99 minus 4.475. And that gets us a percentage of, we're going to be able to do 2 decimal places. We're going to have, we'll get 4 sig figs out of this. What do we get? 36 point something, 35 point something. What do we get? 35.53% oxygen. Okay. Now, what we're going to do with percentage composition information is we're going to look at that percentage composition and say, well, if that is the percent, what's the formula of the compound? So what we're going to do now is we're going to look at these percentages and we're going to come up with C9H8O4. We're going to work this backwards. Now, that involves what's called an empirical formula. It is empirical and molecular formulas. So molecular formula is a multiple of the empirical formula. Or said another way, empirical formula is the reduced, simplified form of the molecular formula. It is no different than reducing fractions. If we have a molecular formula down here of C6H6, the reduced form of that is simply CH, right? We could divide it by 6. If we have C4H4, here's the problem. You have two different molecules that have the same empirical formula, CH. We're going to reduce it by 4. If we have a molecular formula, C4H6O2, my empirical formula is C2H3O, right? We divided by 2. And if we have, put that on the screen. And if we have H2O, there's nothing we could do. It's going to stay H2O. Now, another way to look at that, and here's what we do coming up is it was a 6 that we divided by, right? I'll just put the empirical formula here. It was a 4, right? And here, 2. And here, 1. Okay. Here is the steps. So again, we're going to go backwards. We're either going to be given grams or percents like this. And we got to be able to calculate backwards to get the formula. So here's our steps. Step 1, get grams. Step 2, convert all the grams to moles. Step 3, divide all moles by the smallest moles. Step 4, if not whole number ratios, make them whole number ratios by multiplying all ratios by the least multiplier needed to create whole numbers. What the heck does that mean? So here I put a step 4 clarification. This is what it means. We know that we have whole numbers right here, correct? We don't have any fraction. We don't have any halves. You don't have half a carbon in a molecular formula. But let's say you do through step 3 and you come out with something that looks like this. .5 H3. To make this whole number here, we would multiply by 2, right? 2.5 times 2, and we'd get a formula of C5H6 for a final formula. If you got C 1.25, this is 1 1/4, right? We're going to multiply by 4, and we would get C5H16. And this is 1 1/3. We would multiply by 3 to get C4H15. So next time we meet, we will finish this up And if we look at our schedule, that is exactly what it says on our schedule, that Friday we should be finishing this. Exactly on schedule. So at this point, you can try some more on this quiz. Let me circle which ones you should be able to do on here. Or put them down. So you should be able to do on this quiz through numbers. (21), 22. You should be able to go through 22 on this quiz now, to keep track and stay on course. You should be able to do 1 through 22. I think there's how many? There's only 25. So on this quiz, you should be able to go through 22. All right, stay out of trouble. Make sure you're trying to get Odyssey loaded on your computer for labs.
Quick question.
Close this down. You too. That just closed out. Yeah.